Vince Mangini with Food 21, back with another installment of the Barley Report. And if you recall, earlier this year, we got our seed into the ground and we followed their progress through spring and summer and the actual harvesting. And now we're at the point where we're going to convert those grains into malt. And to do that, you need a malt house. And luckily in Western Pennsylvania, we have CNC Malt, located in a little town of Fennelton, just outside of Butler, PA. And Brendan, the owner, who is the maltster here too, head maltster, he's going to take us through the process of what it takes to convert these kernels into malt. And hopefully what we can get from this is an appreciation of the process. It is scientific in nature, it's repeatable, but there is a sense of a little bit of artistry and craftsmanship involved in this process, and hopefully Brendan can educate us on that, and we can get a little appreciation of what's involved.
So barley comes to us in many forms, from 55-pound bags up to tractor-trailer loads. So when we're receiving barley by the tractor-trailer load, we need to get that unloaded rapidly and into something that'll hold a tractor-trailer load plus worth of barley. So we use a portable auger, which has been ported elsewhere, to load it into our receiving bin, which is being modified at the moment. After being received, then we clean the barley, and upon cleaning it has to be dried to a storable condition. So the back bin behind us is the drying and storage bin, and the fuel source we use for drying the barley is wood pellets, our wood pellets. And so there's a biomass furnace in the back that goes into a manifold that mixes the air to just the right temperature, so we keep the barley alive.
And that's part of it. You know, the malting is science to it. It's been done for thousands of years, but the artistry part of it is how to have the appropriate amount of heat and the time of the heat. The process is steeping, and that's where water is added to the kernels to start the germination process. And we're standing in front of Brendan's big steep tank.
Yeah, so this is probably the most critical part of the process and the first step in actual malting. So everything else could be any other industry. Malting is where we're taking grain and getting it to grow and then drying it out. So the adding moisture to the grain takes about 2 days, and it's not done all at once. You have to do it through several steps so you don't drown the grain. And during that process, the same, we have to keep air moving so we don't overheat the grain as well. So we're going from roughly 11-12% in storage up to about 44% moisture. So it's getting that barley to take up that water, and there's different fans and blowers.
So what happens in the tank?
So in the tank, when it first goes underwater, we have all these hoses going around to little induction nozzles that stir up the barley. So that helps. While we cleaned it out there, there's still straw and debris and stuff that isn't of interest to the brewer or distiller. So when we stir it all up, it removes a lot of that dust, and we could overflow the straw off the top. So it's really kind of a cleaning process. So then after being underwater for about 8 to 12 hours on the first steep, the water's drained off and the barley's retained. And I don't know if you can see the cone through this man door there, but that's the purpose of that. Then we have to draw air through it. So there's a duct in the back that sucks air through to keep it cool and keep it oxygenated. And then you repeat the process.
How many times?
About 2 to 3.
Not only do we get it to take up moisture while it's underwater, but we get to float out the little...
I can see we have a little bit of the sprouts starting.
Yep. But the dead kernels and stuff that aren't going to contribute, we could remove at this point as well. So water's good for cleaning and separation.
We grew.
That it is, the Odyssey 2-row spring barley. This is fresh out of steep, and so what you have here, you can see those little white parts there, the emerging rootlets. That's about a perfect steep outlook, and if you smell it, it has kind of a spring rain kind of fresh smell to it, so that's very good.
And this is more of our stuff too, a little bit earlier?
Correct. This has been out for about 2 days now, so you can see those roots have gotten quite a bit larger, and probably about another 12 to 24 hours this will go to the kiln. And you could test the how well it's progressing by kind of peeling back. The side opposite the roots is where the little plant grows out. and that's called the AccuSpire, and you can see he's about full length there. So that's indicating very good modification, so I'm thinking it'll be closer to this evening. If they're all uniform, this will be going to the kiln, and so far your malt's malted out very uniformly. So
That's great.
well,
Oh, wow.
yeah.
This is pretty impressive.
Yep. So this is more Westmoreland County barley. This is a 6-row variety called Thoroughbred.
Ah,
That
okay.
if you remember when we were down looking at your fields, the Heinekels had some growing right next door to you there, and they were saving theirs for feed, but luckily Fred Swazak had some more from Lone Maple Farms that he was willing to part with. So we purchased all he had, and this is about half of it. So we have about 3 tons here in this room growing, and I'm very happy with the way it's coming out, very uniform.
Now, will this have a different flavor profile from ours?
It will. So the kernels are a little smaller. They're going to have a little higher nitrogen, a little more enzymatic activity, but the flavor profile, we have a beer in the back I think we could taste it in. It's definitely unique. It's this would be typical of American beers, all American beers, especially pre-Prohibition beers.
Oh.
So for someone looking to do a more historical type of ale or so, this would be the barley you would want to use.
Because we're actually talking about working with some of our stuff for the old Hannistown ale, and maybe this would be a good grain for it.
Interesting, yeah. Okay. Definitely be a candidate.
This is nice. The next part of the process is the drying. So we've had the barley on the floor, and it's started the process of growing basically. And so now we've got to get it to stop. And it brings over to the this is CNC's big kiln. And Brendan's going to talk to us a little bit more about what happens here, part of the magic.
All right, so it's almost kind of the reverse of where we came in, right? We had to dry it down, so that's the same, and then we're going to have to clean it up after this. So the purpose of drying, like Vince had kind of mentioned there, is to pause the process. So if we allowed the plant to keep growing, it would break down starches more, and there'd be less extract for brewers. So at this point, we have a lot of different paths we could take. If we want to maintain as much enzyme potential as possible, we're going to dry at very low temperatures, and that would be something distillers would probably be interested in. We could create a lot of different flavors by the temperatures that we hit and whether or not we recirculate moist air. So there's this becomes an artsy part as well. So we could really develop again, different styles of malt depending on what we do.
Basically, it's the flavor profile of the beer we're creating here. So the craft brewer is going to ask you or tell you what they kind of want, and then this is where you do the work and create that for them.
Correct. And on the nuts and bolts of it, there's a wedge wire floor here to allow the air up through. It's larger than you'd have in a mash tun. I think it's 68% open area or so. Large air plenum underneath.
So the hot air is down here.
Exactly. So all the air blows in, and to make sure we have even air distribution, you want to give it a lot of space so that it could come up through the grain. The grain bin will sit about this deep. We learned on our pilot system that sometimes you need a little bit of extra head space, so we have more space up above for distributing the barley evenly and making sure that we could fit in the full batch. So we could walk back to the furnace and look at that afterwards, but basically air's coming in just opposite us underneath, blow it up through, and then it exits out the window there to be exhausted to the outside.
Maybe this is a stupid question. Will the kernels fly around in here? Will they sit on the bed? Or?
No, so we are putting air through at a much higher velocity than we are out in the drying bin, but it's still not high enough to blow through this thick of a bed. Now, if we were to have a very thin bed, yes, you could have what's called like a volcano or something where it'll blow through, and then that's not good because you're not getting even air distribution. So it's a matter of keeping the air flow.
We're not quite done with the malt yet. The brewers need a clean product, and so all those little ends on the kernels need to be taken off, and that's what this machine does. And we have an example Brendan's holding in his hands, kind of a before and after product.
Yeah, so essentially this is green malt going into the kiln, and then this is malt that just came out of the debearder there. So all those little rootlets don't belong with the malt in the mash tun. So the machine spins around and beats them up, knocks off the roots, but they remain with everything. So then we take this outside and run it through a screener again to remove the roots and further clean up the malt.
And it's ready for bagging. We're gonna head over to where we bag it. After everything's, all of the malt has been cleaned, it comes over to the bagging facility, and basically it's a pretty easy process. We just put it in top,
Yep.
and it's weighed here, and it goes into the nice CNC bags, and then it's sealed shut.
Yes, sir, that's it. Pull the lever and the scale weighs out about 55 pounds, whatever you dial her into.
Part of the process here at CNC too, it's quality control and quality assurance. So, and that starts when they receive the barley from the farmer. We've got to make sure that it's a good product. And so part of that is it's sent away to be tested up at Hartwick College. But part of the stuff that Brendan does here is also involved too. And,
All right, so probably the most important test we're running on grain coming in is germination. So it has to be able to grow and grow well. So right here we have 2 germination tests running of the same variety of barley, started on the same days, same year. One was grown up in Sandy Lake, one was grown right here in Clearfield. Now this is the 3rd day of the test. Every day we go through and pick out the seeds that grew and count them. And so we're looking for it to germinate 95% or better by day 3. So this will be the 3rd day here in about another hour. So we'll count these up. These should, for the test to be proper, be conducted at constant temperature and humidity. So that big stainless refrigerator looking thing in the back is the vessel in which we do that. It'll maintain temperature to 1/10 of a degree and humidity to percent. It's important too to have a good representative sample. So those brass sticks in the back are used for grabbing samples from either trucks or bags. You drive this through, open up the column. That way you get a representative sample throughout the column, close it, and then it pours out the end. And you would do that in several spots. And split the sample down using the rifle box there, that stainless box. Sends half of the sample one direction, half the other way, and you split this down 50-50 until you have everything to what you want. And that way you know you're sending as representative a sample as possible off to be tested, or that's what we're working with here.
And the quality control doesn't stop there too. It's got to be maintained all the way through the whole process. And so we have another machine over here that when we were starting with the germination part of the malting, Brendan's going to talk about that as well.
Right. As we go through steep and germination, we're very concerned about moisture. So one of the most important machines to us in the lab is this moisture balance. So the way this works, there's a very sensitive little scale on there. We put a sample in there, and then there's a halogen lamp there that heats it up and bakes off the water. And the scale at the end of it tells you what the percentage of moisture is in that grain. So 40.87% is that barley at the end of steep, so it'll do one more immersion before we put it on the floor. Now, when we're all done with the process, we need to find out if we did a good job or not. And so a quantitative way to measure that is friability, and we can look at that machine now as well.
Great.
So this machine, once we're all done, we can find out if we did a good job or not and make improvements in subsequent batches. So the way it works, there's a sample in here ready to go, but it's loud, so we won't start it just yet. But there's this screen that spins around and around, and there's an arm in there that presses the malt against the screen here. So the malt that has been modified and is nice and friable will fall through. So you collect your good portion of your sample here and then discard it. And then the remaining bit in there is what we weigh and see what is left over. So if we're seeing whole grains, whole kernels, they may have been dead from the start of the process. That's why we run the germination test. If we see partial kernels, half kernels, that might have been something that didn't germinate long enough. and so it's left partial, or it was chopped up by an auger or something through all the movement of the grain from A to B to C. So that's at the end of it, if we're seeing those issues, we could go back and try and correct to make a better malt in the future.
So there's still part of the process. We can go back and rectify anything or try to help the malt along the way so we can get the optimum product.
Correct. I guess the final and most important is the sensory analysis, so more of a qualitative type method. So this was a method developed by Brees in partnership with New Belgium, and Lindsay Barr is one of the founders of that, and she's since left and started a company called Drought Lab, where they do a lot of sensory analysis on malt and hops and beer and things like that to make it more scientific and less subjective. So if you approach everything the same every time with a large enough population and panel, you could have more exact data on what a flavor is, which is something that we could argue over.
And I may have to step in here for a second. Your background. It might help us with this part right now.
So chemical engineering is what I went to school for, and so the chemistry part of it makes sense to me. So if I'm off on a tangent, then thank you for keeping me back on track. So what we've done here is we've made a dilute mini mash. So 150 degrees, 147 degrees or so, we hold the malt solution at for 15 minutes, then we filter it out so we don't have chunks, and then we have a nice solution that's very drinkable. So when we get to these teas, it just makes you feel good and you want to drink more. So we're looking we don't want to be overwhelmed by the sweetness, which is what you would get of tasting wort or, you know, runoff from your mash tun. So what we're going to do here is taste these and see what they taste like. So right here we have a base malt. So this is what we call our American ale. It is commonly referred to as two-row. So all around good base malt. Here we have a crystal malt that's mixed 50-50 with the base malt. And the reason we have to do that, we have roasting as well. So in a roaster, you typically just crush your enzymes. There's no power left to convert the starches to sugars and get a real idea of what the flavor is. And besides, in a mash tun, you're not going to use 50% crystal anyway. So sometimes we knock it down to 15%, try and be more representative of what the brew will be. So we mix the base malt with the crystal to get a flavor. And for fun, we did just a straight crystal. So we look at color, we look at flavor, and then we try and map it out, see if there's any off flavors. Like grassy might be an example of an off flavor we could correct in the kiln. So if you're finding grassy flavors in a light base malt like a Pilsner, then maybe what you have to do is increase the temperature slightly to drive those flavors off.
So there's still a little work that can be done here with the malt.
Right,
and to change the flavor profile.
Correct.
So we're still. So we are wrapping up our tour, and we're in basically the warehouse, and we have the finished products here in CNC's newly designed bags. And Brandon can explain a little bit more about what's going on here and how we get out to the craft brewers.
Yeah, so fresh out of the kiln, we like to let our malt usually age for about 2 weeks before shipping out, and that helps with on the fermentation side and allows flavors to mellow out a bit. With a few exceptions, crystal malts are best used as fresh as possible. But
CNC's mission includes being eco-friendly. So what they've done too is they've included a biomass furnace, and so they can burn different types of malt, or even old malt, or even wood. So Brendan can talk a little bit about that real quick.
Yeah, we have a unique position here. There's a lot of trees in Pennsylvania and a lot of telephone wires that need to be trimmed. So the wood chips that the crews remove, we have a home for them here, as we can burn them in the furnace for the heat source. Runs best on wood pellets, so we have wood pellets, and then as Vincent said, other combustible material like old barley works just as well too.